Now in this example we are required to calculate delta G at 29 degrees, and we have a reaction with reactants and products, so we are not at equilibrium. And first of all we need to write down the equation in this particular case. So we know that delta G in this case equals minus delta G at the standard conditions plus R times T natural logarithm of Q. And Q is described by the mass action ratio. So Q we can write Q equals the concentration at the given time point, so that would be concentration of C times concentration of D divided by the concentrations of the reactants, so that would be concentration A times concentration B. And of course we can simplify this equation a little bit, because we know that delta G is nothing else but RT natural logarithm of our equilibrium constant. So we can write delta G equals minus RT ln K plus RT ln of our mass action ratio, and we can simplify that and we can write this as equals RT natural logarithm of the ratio between the mass action and the equilibrium constant. So that makes it a little bit more palatable. We also need to be mindful that for our T is always given in Kelvin, so we've got 273 Kelvin plus 29 degree Kelvin, and this then gives us 302 Kelvin. We've been given 8.31 for our gas constant. So what we really need to do is we need to calculate our mass action from the numbers that we've been given. So this would be Q equals 10.59 millimolar times 2.10 millimolar divided by the concentrations of the reactants, and that is 1.47 millimolar and 5.61 millimolar, and we see the units cancel out. And that's quite nice, because also our equilibrium constant doesn't have a unit, so that's quite handy. So all we need to do is we need to put in the numbers here. So we've got 8.3 joule per Kelvin and mole times 302 Kelvin times ln, and if we do the Q, we can calculate that, and that gives us, if we put that in a calculator, that gives us roughly 2.7. So we then have ln 2.7 divided by the equilibrium constant, that gives us 10.86. And this one here gives us negative 1.39, and we get a delta G which is roughly negative 3.49 kilojoule per mole. So that means that under these conditions, where we have these concentrations here for our reactants and products, the reaction is not in equilibrium, it is feasible, and it goes actually from A plus B, C plus D. The reaction still is moving from A plus B into this direction. So the reaction is feasible, and it is moving towards the products. So I hope this